Okay, so like I said, so happy to see you here. Welcome to what is the latest edition of the SEDC webinar series. So you all know this really well by now. These sessions are meant to bring together what are the world's best economic developers to discuss timely topics or strategies to sharpen our collective spears and to ultimately enhance professional capacity to accelerate economic development even further and faster in the American South, which we love to say is the world's third largest equivalent economy. So with that said, I want to get out of the way quickly here so I can sit back and learn as well. We're going to dive right in to the weeds and welcome you to the Economic Development 4.0 webinar led by our great friends at Active Infrastructure. So many of you know Jeff and Mike, but for those meeting them for the first time, maybe new members to SEDC, let me read a bit of their bios here, and then we'll turn the floor over to them. So first, we're excited to have Jeff Ziegler with us. Jeff is the founder and chief executive officer of Active Infrastructure. Mr. Ziegler brings more than 15 years of institutional real estate experience, during which he has led the development and acquisition of projects in 11 states, exceeding $3 billion in value, including over 13 million square feet of build-to-suite transactions for a leading multinational technology and e-commerce company. Prior to founding Active Infrastructure, Mr. Ziegler was a partner at Dermody Properties, a national real estate investment management company, where he ran the company's national accounts group. During his tenure there, Mr. Ziegler sourced and led the development of the largest build-to-suite and speculative development transactions in the company's 60-year history. Prior to that, he was the vice president of development of KTR Capital Partners until its sale in 2015. So thank you, Jeff. Welcome to SEDC, by the way. We're really thankful to have you here. And then second, many of us know Mike Grella, who is the Chief Infrastructure Officer for Active Infrastructure. Mike is responsible for the sourcing and executing of the company's projects throughout North America. He brings over 27 years of experience in economic development, workforce development, site selection, community engagement and planning, and public policy. Mr. Grella is also the founder of Grella Partnership Strategies, GPS, and economic development and public advisory firm. Prior to launching GPS, Mike founded and led Amazon and Amazon Web Services economic development teams, facilitating investments representing over $10 billion of capital investment in over 100,000 new jobs in over 24 states and 15 countries. Mike supported the launch and expansion of Amazon data center regions around the world and countries to support hyperscale data center development for several large tenants and developers. Prior to joining Amazon, Mike advised more than 100 Fortune 500 and large privately held companies on site selection and economic development matters. So a really great team here today. We're so excited to hand it over in just a sec. Before we do, as we move through this, please be thinking of questions for Mike and Jeff. If you have something that hits you right in the moment, pop it in the chat. They may get to it on the next couple of slides. If they do not, they will get to it at the end, where we will have a Q&A session. And at that time, turn your cameras on, ask a question. Let's just have a discussion while we have time here. So this is being recorded. After, it will be on the SEDC website, available for you on demand anytime that you need. So we're so excited to turn the floor over to Mike and Jeff. Welcome, and thanks for being here today.
Thank you for having us.
Thanks. Appreciate it.
Thank you for the wonderful introduction of both of us.
Absolutely.
Just to hop on your tailcoats here, Mike and I been working together for a little over a decade. When I started in the real estate business, Mike joined Amazon, where we were he was a client of mine, and developed fulfillment centers and data centers around the country. Active Infrastructure, we're headquartered in New York, and we have offices in Columbus and Atlanta. Throughout our team, we've done about $7 billion of data centers and industrial developments throughout the country, including brownfield redevelopment, clean up greenfield development, and converting fallow assets to income producing and tax rateable producing properties throughout the country. We also, just through our relationships, have and our past background, have relationships with Fortune 500 companies, to name a few, whether it's Fortune 10 multinational e-commerce and cloud computing company that the name was briefly mentioned, or from the manufacturing side, electrical vehicle manufacturers. Throughout our Rolodex, and we have a lot of customers, not only in the data center business, but also in the advanced manufacturing and e-commerce business. So what exactly is a data center? About 15 years ago, people didn't know exactly what a data center was. We always like to start off and explain exactly what one is. Data centers are essentially warehouses that are storing data. In there, they have processing and cooling equipment, as well as storage equipment. And that is what allows the world to basically to spin. Everything goes back to a data center. And people often don't realize the interconnection between the data centers and everyday life. The things that separate a data center from, say, a regular industrial building is some of its requirements as it relates to utilities. A lot of it also relates to electric. We'll touch later on in the presentation about electric, but also site locations where these buildings are set up. And then when you get inside, there are where in a regular warehouse, maybe now they're going to 36-foot, 40-foot clear. You're going to have smaller areas within a data center because you don't want to be cooling space that you don't need. Also, the idea is to get as much of the processing and storage into the building, so you'll have aisles that are specifically cool aisles versus hot aisles. And then the requirements of just being constantly on. You cannot go down. Most of our clients in the data center business are known as the 5 nines. They need to be operational for 99.999% of the time. And if they do go down, whether it's because the HVAC equipment is no longer working, power is out, there's an interruption to their fiber network, they have major issues with their customers, which means then if we own the building, that we're going to have major issues with them. A lot of times that relates to significant rent credits to the tune of, if they're down for more than 0.002, they could get a 25% rent abatement for that month. But the overall idea is to make sure that the buildings are up and running, and there's incentives to keep them there.
You can bring a chair over here as best I can do.
Yeah, Jeff, I'd add to that in terms of data centers. There are, they come in all shapes and sizes. We kind of look at them as single buildings, and what's on the inside is unknown to most folks. But the type of processing and actually the site selection criteria for different types of data centers can be pretty dispersed. So you've got your single tenant co-locate or multi-tenant co-location data centers. So the QTSs or the Digital Realties of the world. Co-location, you could have 5, 6, couple of dozen tenants that are renting racks and space in there. You could have a single tenant enterprise. So a JP Morgan Chase, banks that have their trading floors, et cetera. They can have they'll have their own what they'd call either on-premise or standalone enterprise data centers. You've got storage or disaster recovery data centers, which they're not as latency or data speed sensitive, and they're usually going to be in more rural locations, quote, outside the blast radius of major population areas. So, for example, like an ADP for their payroll, have to make sure that that those critical systems are running, and if there was ever a catastrophic event, that their backup systems would be up and running pretty quickly. And then you've got your hyperscale campuses, which are the Metas, the AWSs, the Googles, Oracle, Microsoft. These are the multi-building campus deployment. So much of what we'll be speaking today is about sort of these hyperscale multi-building campuses that have very large utility load requirements, but certainly there are going to be different requirements depending on the type of data center and whether it's being used for storage, backup, high performance compute, research and development. And then the last type of data center is the edge data center. So edge is really like, if you think about a last mile warehouse of getting that package from to folks' houses as quickly as possible after they've been sorted. It's the same thing for edge. So you don't want your computing instances to have to travel 500-600 miles away. And even if the biggest data center region in the world is in Northern Virginia, if you're driving your Tesla or you are using your Netflix, you're on a Zoom meeting, etc., it's really important not to have that high latency or that buffering where there could be a lag or a delay. And particularly on things like autonomous vehicles, self-driving cars, smart traffic lights, etc., you need those decisions to be made instantaneously. So edge data centers are typically located very close to population centers. And so they have stricter requirements in terms of site selection and having to be much closer to the customer. So with that, we'll go back to the presentation.
Good points, Mike. And then, I mean, the last one on here was and you touched on it briefly, was the security infrastructure. A lot of these buildings are nondescript, but what's going on in there, is important often to, the national safety, or the economy. For instance, Visa and MasterCard and all the credit card companies, they have their processing facilities. You can imagine if something happened to one of those, how that would impact not only the US, but world commerce. So from a security perspective, you often can't plant these immediately just next to something that could be even a terrorist target. So one of the banks who we worked with, they will not allow their data centers to be near any building that has a government contract in it, because they believe that to them is a potential target, and they don't want their system to go down due to someone going after the government. So from a security perspective, that is one that is often not seen, but is very important in the siting of these buildings.
Yeah, and Jeff, I'd add to that on the opposite end of the spectrum is that you have private, or what they call GovCloud deployment. So the big hyperscalers like Google and Amazon, Microsoft, you may have heard of that multi-billion-dollar JEDI contract that was subject to dispute several years ago. DoD, the acronymed military and defense agencies, spend tens of billions of dollars a year on cloud computing, and a lot of their data centers are co-located or on-premise or adjacent to military and defense installations where you actually have to have that high level of security depending on the level of security clearance required.
So when looking for a site, some of the green flags that we're looking for are abundance of water. Data centers typically use a significant amount of water for cooling. Over time, the industry is shifting towards water light and ultimately waterless cooling, but for majority of the buildings, they're cooled via taking in water from the public utility, let's say 55 degrees, recirculating it a couple times through heat exchangers that pull the heat out of the air, and then releasing that water back into the sanitary sewer system while they take new cooler water from the water system. Gray water, so water that is lightly treated, is acceptable to most of our clients. So if there's a limitation on water capacity in an area, we have seen some of our customers, and we're currently in the process of doing this in a different state, of working to create a gray water or purple line, excuse me, purple line system where that water is not potable, but it doesn't have any pathogens or anything that is that can be hazardous to anyone's health, and that water is cycled through just as if it was clean water, and sent back, and that allows there to be a little to reduce the strain onto the water infrastructure. Power is the #1 item that we're looking for and our customers are looking for. So proximity to high voltage transmission lines is key. Transmission lines that have capacity in some markets now, there's transmission lines that are crossing all different paths throughout the market, but there's no capacity on those lines, so they're having to run new lines. Proximity to electrical substations and switching stations. So if you're bringing in power, let's say 500 kilovolts, right, if you can't take that at no, that's not acceptable voltage for any operation to take. It has to be stepped down. So taking it to a substation where it's being reduced to an acceptable design from a receiving side is important. If you're not close to the electrical substation, the ability to build one, whether it's on site or nearby. We've been willing to build our own substations as well as build substations that are both public and private. So the region in the area, if there's a limited amount of electrical capacity left, we're building a substation. We will upsize it and work with the utility for them to utilize that. Having redundant and reliable power is key. In the event that one of those high voltage transmission lines goes down, there needs to be at least one other path for electricity to get to the site. And then between those minimum two different routes, it has to be extremely reliable power. Because if power goes out, what happens in all the buildings is backup generators kick on. But no one wants backup diesel generators to be running long term, and it's not efficient from a standpoint of environmental impact. It's not sufficient or efficient from a cost perspective. So that really is supposed to be the true backup of the backup on these on our buildings. Being near multiple dark fiber providers, so fiber that's already in the ground that may not be utilized yet is important. And then natural buffers from surrounding sensitive noise receptors. Don't want to be near residential or schools, or something where there could be a potential impact from the operation on the neighboring businesses. And then just red flags that will impact the site's location is high natural disaster risk. Believe it or not, there are data centers that are on the San Andreas Fault in California, but that's because they have to be there. But really not looking to be not going to site these in areas that have extreme climates, whereby it's getting there could be significant or higher potential for an environmental impact to the operation, whether it's flooding or strain on the electrical system that's going to limit the amount of electricity available. As I touched on before, residential neighborhoods, proximity to activities causing vibrations. So areas where you have blasting, so quarries, that's something that could be impactful. And then proximity to rail lines or highways where there's a significant amount of hazardous cargo being traversing nearby.
Yeah, I'd add to that. And there was a comment in the chat about renewables. You know, I would say, you know, 5, 6, 7 years ago, renewable, while I was working for a hyperscaler, renewables were a top priority. And it's not that they aren't right now, but there's such a shortage of power that people will take power where they can get it, irregardless of what the fuel mix is. So it could be 80% coal, and that's great. If you can get hydropower in Eastern Oregon, upstate New York, Buffalo, Western New York, there's a handful of areas around the country where you can get green power, and that's great. But it is right now it's the new gold rush is to find power anywhere. Certainly can enter into power purchase agreements for solar and wind, but in terms of the site selection for the actual data center, what we're seeing more is the PPAs, the power purchase agreements for the renewables, are completely bifurcated from the site location of the data center itself. But all things being equal, yeah, green power is important.
Yeah, and when it comes to green energy, hydropower is number one versus solar or wind. We've seen customers willing to invest in hydropower plants a lot easier than funding windmills or solar arrays. Hydropower typically does not have an impact to the region where large region versus a windmill. And solar, often there's an argument that you're taking up usable, whether it's farming land or developable land for the solar arrays. So our business.
Yeah,
Go ahead, Mike.
Yeah, I was just going to say that, folks are looking for, we spoke to a customer and we were talking about renewables, and they're like, what we look at when we look at megawatts, we look at baseload generation. We look at what reliable power, is available. And that if it has to be sunny out or the wind needs to blow in order for us to be able to meet our power needs, that's a problem. So it's not that it's not happening, but this really comes down to resiliency and reliability. So baseload generation coming from traditional power sources is really the number one priority. But yeah, what's powering the demand for data centers? It's the IP traffic, and you see the exponential increase in the amount of data that's being used. And what's interesting here is that I don't believe barely captures ChatGPT and OpenAI, and I believe that once those 23 numbers come out, you're going to see that hockey stick growth continue significantly and grow even higher with the amount of streaming and connected devices that are out there.
Yep, and we took an aerial of Ashburn, Virginia, so just north of Dulles Airport in Northern Virginia. And in 2002, you can see the landscape that predominantly farmland. There are some preliminary or some early data centers that were located there. I mean, Ashburn is about 25-minute with no traffic drive into DC, so around the federal government. A lot of the telecom companies were founded there. AOL was based there, MCI. And then in 2023, you can see how the entire area has been filled out, and virtually every one of those buildings is a data center. There is very little, if any, land left in Northern Virginia for data centers. And what often happens, or what happens once one starts building, you start building an ecosystem, most of the operators and service providers will follow. And that has resulted in 70% of the world's internet traffic goes through Northern Virginia every day. As the growth in our industry continues, our customers are investing a lot of money in into their operations and into their expansion. You're seeing a lot of announcements of these mega campuses, where those are predominantly for the hyperscalers, where you're not doing one building, you can be doing 4, 6, 8, in some instances 20 buildings that are all in the same area. You're taking advantage of existing infrastructure as well as cost efficiencies to locate a lot of your operations in one location. As Mike mentioned earlier, most of these sites are not going to be in main areas and in major metropolitan areas. They're going to be outside, and we'll discuss those in a little bit.
Yeah, the drivers of data center expansion, and this is only a couple of months old. The U.S. hyperscale data center market's going to exceed $100 billion over the next 5 years. And as Jeff just mentioned, that growth is a significant part of that growth is going to be taking place outside of the top 5 and 10 data center markets due to power constraints, land constraints, and policy, regulatory issues, NIMBY, et cetera, which we'll continue to talk about. But what's driving the expansion? IoT, robotics, machine-to-machine connections, the use of Siri, use of Alexa, your Ring doorbell, mobile apps, all sorts of connected devices, connected car applications, et cetera, Wi-Fi hotspots, and the amount of Wi-Fi networks are absolutely exploding. You hear that Google and a lot of the major tech companies are creating their own their own Wi-Fi networks, and they're deploying hundreds of satellites into space and low orbit satellites to provide additional bandwidth to customers. And that all requires compute power. And so there really is an insatiable demand right now for compute power that's supporting all of these Industry 4.0 disruptive technologies like robotics, AI, machine learning, connected devices, 3D printing, et cetera.
And most of the devices, I mean, think about just around your house, most of those devices are always on, whether it's an Alexa, a Google Home, a Siri, or a connected light switch, a Ring camera. They're always on, and they're always sending and receiving data to a centralized location that's processing that. Like a Ring camera, it's consistently taking just a screenshot and sending it back to a processor, where it's comparing the image from a second ago or 2 seconds ago to what it's seeing and determining, is there movement? And then when there is movement, needs to start the storage of whatever that movement is while it's sending a notice to your phone, to your computer, to your watch, whatever it may be, that there's movement on your Ring camera. So the amount of data and processing just continues to grow exponentially as more and more people adopt smart home technology and then move over to the smart, to electric vehicles and connected vehicles. When you're driving a Tesla and it comes across an accident, or driving, let's say, with Waze, that information needs to go up and then be sent out to thousands, if not millions, of different data receivers, whether it's a phone or another app that takes that information and puts a traffic notice on XM traffic, something like that. There's constant data flowing all around us, and data centers are what process that and store that information.
Yeah, and that's only going to continue with Fitbits, health monitors, wearable technology. You now have chips that are actually being put into transplant patients, cancer patients, heart patients, where they're actually monitoring how medicine is getting dispersed and administered, constantly monitoring vital signs and helping provide direction of where, whether it be during a surgery, post-surgery, or on a permanent basis. So in medicine, telemedicine, surgery, you're going to see continued proliferation of these devices that, as Jeff said, they're going to be on 24/7, 365. So external factors impacting site selection trends, the NIMBY opposition is something that is, I don't want to say it's new to data centers, but for quite a, I'd say the last 5 to 10 years, up until maybe right around 2020, the amount of opposition at data centers was quite measured because most opposition related to traffic and noise and trucks going in and out, potholes being created, et cetera, low wage jobs. And that was really the majority of the NIMBY concerns. So you saw a lot more of that on warehouse type of projects, as data center projects are, they run 24/7, 365. So you have 3 shifts of employees. So not a tremendous amount of job creation, but significant to begin with. And we'll certainly talk about those impacts and multipliers. They're not causing those types of neighborhood externalities where you're seeing and you're smelling and you're touching the nuisances that are created by the project. But nonetheless, the concerns about energy usage are real. The concerns about aesthetics as data centers are getting built closer to or adjacent to residential neighborhoods, that the design element becomes extremely important of making sure that the buildings, from whether it be the green space and the landscaping or the building envelope design itself, looks more like a corporate office building or office park than it does a warehouse, is extremely important. And if you have to go through the zoning or rezoning process for a piece of data center dirt, it's a cumbersome process that can take anywhere from 12 months upwards to 2 to 3 years. And so the price of entitled data center land in areas like Santa Clara, California, Northern Virginia, is $1 to $4 million an acre per year. And even in other markets like Dallas and Chicago, Columbus, Ohio, Atlanta, you're seeing very significant increases in 6-figure prices per acre. So that there's no sign of the prices going down in these primary markets, but it really is a testament to the fact that there's a level of comfort that hyperscalers and developers and their customers have with these primary markets, that it takes a while to get folks used to or to desire to be in some of these secondary markets for certain types of applications. So notwithstanding that the prices of data center instances in Northern Virginia can be significantly higher, or in Northern California, than that of other regions around the country, you still don't see a significant slowdown in terms of demand. Folks still want to be hosted there a lot for a lot of reasons, including they have existing applications that they're continuing to grow and scale, and they don't want to move those compute instances or migrate them to other regions. So that is another reason for the driver of these land prices.
Yeah, I mean, this is the content of this slide are one of the things that keeps me up at night, because it's kind of a circular issue, which is you have land that is acceptable, perfect for a data center. But there's often unfounded concerns about what a data center is and its impacts to the environment and the impacts to the region. So that causes public officials to side with their constituents and really reduce or materially impact the area that you can put data centers, which if it was zoned industrial, often the data center is going to have a lot less environmental impact than that industrial warehouse distribution center. But you have, with Facebook and other social media, the ability to very quickly broadcast something which could be completely wrong, but it's taken as gospel and then causes there to be a limit the amount of land that that's available to the data center business, which causes people to demand more for their money, which causes the developers and the owners to require larger or taller buildings, because that land, if they used to be able to get 100 megawatts onto the piece of land, and they're paying twice as much now, they're going to want to try to get 200 megawatts. But in order to do that, they have to be larger and taller, which causes another issue back of bigger impact now on visual and on the environment. And then you have land sellers that hold on to their land, hoping that they're going to get that data center pricing. And that prevents the construction and development of other residential or commercial retail operations while these owners hold out for the higher pricing. So if there's areas that are zoned or where it's known, this is where we're going to put data centers. And once we get those data centers, right, that's it. At least people know what they're dealing with. Often what happens in that instance is the tax ratables that come off of data centers versus the impact to the region is heavily weighted towards data centers, the positive side of things. So municipalities and officials will want to find more tax revenue by rezoning or allowing data centers in other areas. But the big thing right now is some of the unfounded concerns that are being pontificated in most of these markets. Touching on just where inside some of the operations are going, about 5-10 years ago, most of the racks, and on the right side of the screen here is what a rack looks like, the server racks. These are pretty fancy ones, but nonetheless, that's what a rack looks like. Historically, about 5-10 years ago, the processing speed that were in those was demanded about 20 to 30 kilowatts. You now have multiple providers that are able to get upwards of 300 kilowatts or 10 times as much power demand into the same area, which is causing a very large strain on the U.S. electrical grid. You're seeing that not only in Northern Virginia, where it's been very public, the issues that Dominion had over the last couple of years, but you're even seeing it in areas where historically there was no power issue. So data center and advanced manufacturing businesses moved there, and now there is a large strain on that region. Coupled with a lot of these regions are starting to decommission their coal or other dirty power plants. So there's a reduction of the generation side as well. One of the things that Mike has on his GPS side of the business, 12 of the 12 largest electrical vehicle manufacturing plants are in 10 different states. Right. So there's two that I think there's two that are in the same state in essence, and that's just looking at the demand side. And then you look at where the batteries are for a lot of those cars, and they're in different states. So just from a power demand standpoint, data centers are now competing with the automotive industry, with the battery plants, whether they're battery plants for commercial or smaller for like residential battery backups or battery systems. And then you have the federal government that has been offering the CHIPS incentive and grants to bring to onshore a lot of these advanced technology manufacturing. And that's causing a large strain on the electrical grid. You also have still some hangover from COVID on the manufacturing side of the switchgear and transformers that are needed for these operations. Couple that with limited tech talent, and we're going into an area where there's a significant strain on our business as well as on other manufacturing operations.
So, how are we as an industry responding to power constraints? In terms of what's impacting site selection, the biggest trend by far is data center, particularly hyperscale campuses, being located in secondary and tertiary markets. And this is this is, I believe, a unique opportunity for folks in SEDC. of all of the areas of the country that have excess power, and there's pockets of it, the vast majority of the areas that we've identified as we've done RFIs and are engaged with utilities around the country. We're probably engaged with about 25 different utilities around the country right now on projects in our pipeline or in our existing portfolio. The majority of those utilities and those sites are in the Southeast. And so, outside of Northern Virginia, outside of Atlanta, outside of Dallas being sort of 3 of the top 10 data center markets in the country, in the Southeast, you're seeing folks gravitate, being willing to go outside of the ring. So, within, let's say, Atlanta, going 50, 75 miles outside of downtown or 100 miles. You'd like to be closer to the metro areas when you can, but you go where the power is, you go where you're going to be able to tap into those transmission lines, step down your power and be able to access 200 megawatts in the next 2-3 years. And so that provides a tremendous opportunity for counties and communities. There's several counties in Virginia outside of Loudoun, Fairfax, and Prince William County, which are sort of the big 3 for Northern Virginia data centers, that have announced multi-billion-dollar data center deployments. Obviously, Richmond is also an area in Virginia that's become a very hot secondary market for data centers. You've also got interest in the Virginia Beach and the Hampton Roads area where there's subsea cables. You've got a subsea cable in Myrtle Beach, South Carolina. You've got subsea cables in South Florida. These are all of interest, particularly when combined with available power. Battery storage and off-grid generation are other factors. Looking at areas where you can do a gas-fired power plant, where you tap into the natural gas lines and you bring in turbines and BYOP, bring your own power. This is how developers and end users are looking at solving power constraints in markets where we're being told 7 to 10 years lead time to get the type of power needed to scale a hyperscale campus. Not impacting site selection, there are numerous factors that the industry is looking at, which is server virtualization, reducing idle server time. These are software packages that allow otherwise idle servers to become a lot more efficient and run multiple applications simultaneously. That also helps with the PUE, or the power usage effectiveness of a data center. Distributing power at higher voltages, running hotter. The industry is constantly looking at technologies and chips and servers where you're able to run 1 or 2 or 3 degrees warmer than previous generations of the same servers and chips. And that obviously is positive for the environment, and not having to use the same amount of cooling and the same amount of water as previous generations of technology. And again, developing more energy efficient processing chips and equipment, which is super important as these AI chips are running at up to 10 times the power density of traditional processing chips. So community considerations in data center attraction. There is a significant property tax increment associated with data centers, particularly in states where personal property is taxed. So in Northern Virginia, the ratables that the counties and the school districts are getting off of the servers and the racks are literally tens of millions of dollars a year on top of the real estate taxes. Generally low impact on traffic and noise, light pollution and odor. And frankly, to the extent that there are issues, there are certainly technologies and ways to mitigate that through thoughtful, effective planning and design. Very well compensated jobs. In many cases, average W-2 compensation of data center jobs is near or exceeds 6 figures. These are resilient jobs. These are jobs that are not being displaced by advanced technology because they are the advanced technology. which, contrast that with certain types of, manual labor jobs that might be subject to higher rates of automation and displacement. These are jobs that are here to stay. And as Jeff alluded to, these are a catalyst for a tech ecosystem, attracting other data centers and technology-intensive business and talent. When I was with my former employer and we located our central region data center or campus in Columbus, Ohio, it was not long after that Meta and Google announced their own hyperscale campuses in Columbus and created an ecosystem. You see the same thing going on in Dallas. You see the same thing going on in Atlanta and around the country, particularly in top 10 markets. You're going to start to see that in secondary and tertiary markets, that you may see some of these one-off hyperscale campuses, but typically once one locates, if there's ample power, water, fiber, you'll see numerous hyperscalers and numerous enterprises or co-locators want to be very similar to a gas station. You see one on one corner of the street, and then you'll see one on all four corners within a couple of years. Cons: fewer jobs and other uses. They are energy and water intensive. There are environmental impacts, and the indirect induced impacts are a bit lower because the equipment is not manufactured locally. Most cases, it's being imported from overseas.
And then these buildings are also very resilient in that, and I fight with our guys about this often. I don't understand why you can't just pick up a server and move it to another building. And the response that I get is that no one wants to unplug the purple cable because no one knows where that purple cable goes. And this is a very neat cable tray. Most of the cable trays, good luck figuring out where it is and where it goes. So no one wants to unplug that, because if they do, who knows what's going to happen to the internet or to their customers. So these are very resilient buildings and operations. So often people say, well, aren't they going to be aren't these going to be useless in a couple of years? Like, technology is constantly advancing, and the answer is emphatically no, because again, no one wants to unplug that purple cable.
So, contrast data centers with sort of tech mega projects. So the EV battery, EV vehicle manufacturing, clean tech, other advanced manufacturing projects. They also have a significant property tax increment. Compared to data centers, their direct and indirect jobs are markedly higher than data centers, which is a positive to most communities. But that also means that you need to have the ample labor supply and labor force for that. They are generally well-compensated jobs and resilient jobs. They also have their own ecosystem. So look at for example, Intel's campus in Columbus, Ohio. They expect many suppliers, dozens of suppliers over the next 20 years to locate and expand their own operations within proximity to Intel's campus. And you see that across the country with chip fabrication plants and other types of tech projects. You do have more cons in terms of nuisances for traffic, noise, light, odor, pollution. And again, because of the significant number of jobs, in some cases, these manufacturing facilities can be 2,000-3,000 jobs. It does put a strain on the labor market and drives up wages for existing employers. So it's great for the workers, but sometimes it's not great for existing small and medium-sized businesses that will have to compete for that talent. Those new residents can put strain on the local housing market, drive up prices, drive people out of their homes, and put a strain on other government resources where you need to construct new schools, you need to construct new hospitals and care facilities, government services, et cetera. And if I don't make the point before before we wrap, I might as well make it now, which is, this is why it's super important when you're negotiating with a user to understand what the externalities of a project are. And we have an advisory business where, notwithstanding we're a developer, that we advise communities on how to negotiate these deals. We all want well-funded schools. We want our roads paved. We want our utility grid to be resilient. We want water and wastewater to be in ample supply. And if you don't have a healthy tax base, that becomes really difficult. And frankly, it's a short-sighted win for the community and the company if there's really no tax base that can fund those resilient infrastructure improvements that allow you to grow a more resilient, inclusive economy and have more long-term prosperity. So best practices for tech-intensive projects. What we've done for customers, again, on the advisory side of our business, are mock RFIs, where we simulate a request for a multi-building data center campus, come in and meet with communities, meet with all the stakeholders, the utilities, the water sewer providers, walk through exactly what that process looks like. Can you meet the load? Can you meet the ramp schedule? Can you meet the timing requirement? Speed to market and time to target is everything on these projects, and going through those exercises can be really helpful. Having tailored incentives that are specific to whether it be data center or large scale mega projects are certainly helpful, and having some certainty around the zoning and entitlement process is extremely helpful. Understanding what your shovel-ready sites look like. I will tell you, shovel-ready certified sites, beauty is in the eye of the beholder. Some shovel-ready sites are exactly right. They're ready to be built out immediately. Other ones may not be able to handle 300 or 400 megawatts, or they may not be able to satisfy a user that needs 1 million gallons of water a day. So refreshing and understanding what those requirements are on a shovel-ready site are super important. Understanding highest and best use. We did a highest and best use for a customer 2 years ago. They had taken their best site in their industrial park right in the middle of it, and they built a Family Dollar warehouse on it. And nothing wrong with Family Dollar, but there were a lot of places on this industrial park where it could have gone, and that really should have been a manufacturing facility. And so just be mindful of like where you're deploying projects, that the first call you get, you don't necessarily want to give away your best site. Being very mindful in your comprehensive planning for future mega projects. That is also important as that goes to timeline and entitlement process. And then understanding what the utility and infrastructure constraints are. I know that we have 1 or 2 slides left, which I think we're best left to leave that for the folks that are going to read this offline and make ourselves available. I know that we've got maybe 4 or 5 minutes left. Jeff, if you want to walk through any parting thoughts, and then we can open it up to Q&A.
Well, I mean, just thank everyone for their time today. Mike is a little bashful in the sense of he's been very successful on the economic development side, and that's why we're here. On the data center side, we are willing to look at really any site where there is a path to power, to good power within reasonable time frame. Our clients are constantly calling, do you have something in this area, or we don't really care where it is, but this is what we need. Again, thank you for your time. I know that there are a couple questions that Lisa put in the chat.
Yeah, Matt, do you want to moderate that, or?
I mean, I can hit them
Sure.
there.
Yeah, I'm happy to, Jeff, or if you want to just move through them, I'm happy to sit out too.
We'll go. Yep. So yes, the slides. I think, Matt, you are going to send out the slides. And the supply chain, there still is a significant impact on the critical equipment. However, some of our customers have taken out the sense of they're making their own equipment. They've designed their own switch gear, and internal ring bus and other electrical equipment. So they're going directly to the manufacturers and with their design. So they're not competing necessarily for the same raw materials or raw parts that are going in, but there still is a a large impact. That being said, one of the slides we had, I mean, we're starting to plan 2-3 years out. So you can get generators are back in. You can get the large scale generators in that time frame. Also, you had a lot of people that were purchasing stuff on a speculative basis that have either released their orders, so it opens up a spot, and at the same time, there's less people doing that.
Other questions?
Someone asked about capacity on the transmission lines. Often, we go meet with the power company, and with that, they're going to charge us for a load study where we give them our load ramp or our customer's load ramp. They run that through the system and tell us if there is sufficient capacity on that line, and if not, what improvements are needed. So in one region, came back and said they needed us to do a 13-mile transmission line extension. We said thanks, but no thanks. In another area, they told us, there is there is sufficient capacity on the transmission line. However, we would be responsible for, in this region, the cost to underground the transmission lines from where they connect to our site. In that region, there is a large outcry about having additional transmission lines traverse their region.
That's right. So, I mean, if they're happy to answer any last minute questions, but I'll wrap since we kind of skipped over the last slide about sort of best practices, is really going through this exercise, the mock RFI, I would say harken back to the HQ2 RFP process and how everyone got together, and a lot of the sort of positive constructive feedback from that was it taught us how to collaborate and discuss how to make a project work of that type of magnitude. That was a few years ago. I think it's timely for EDOs and utilities to get back together if they haven't already in the last 6 to 12 months and talk about that type of proactive collaboration. How are we solving for power and infrastructure challenges that we expect over the next 2, 3, 5 years, and really engage in a lot more long-term thinking? If you're going through your strategic plan or a SEDS right now, to really incorporate shovel-ready, infrastructure-ready sites and thinking about what it looks like 5 years from now, there is a huge shortage of mega project sites and data center sites out right now compared to what the supply or compared to what the demand is. And getting folks together and having an engineer, consultant, advisor come in to really take a hard look and ask the difficult questions and make sure that you're master planning your community, or if you're doing a CPAM or a comprehensive plan amendment, that you're doing it in a thoughtful way that puts you in a position to win these types of advanced tech data center large investment projects.
Well, this was fantastic stuff, Mike and Jeff. I learned so much. Like you said, yes, we will send you the slides. If you would like to have those, just go ahead and make a request to Matthew Darius or I. We've already sent a couple out through the life of this. Also, it will be online on our website probably tomorrow, if not tomorrow, by the end of the week. So we'll continue to publicize that throughout the coming months. So thank you so much, Mike, Jeff. Thank you for all that you do. Thank you to our members for moving us forward in the American South and being part of the SCDC family as well. We'll stay on for another minute or two if there are questions, but if not, we very much appreciate your time and look forward to seeing you the next time.
Yeah, happy to answer any of the questions, or you'll have our contact info. Feel free to contact us offline. The 10 years, the comment about that, the planning cycle for a lot of our customers are now going out 10 years. So they're looking at where do they need to be in 2034, and they're planning for that today. That is a paradigm shift from about 5, 6 years ago, where most planning cycles for infrastructure were somewhere in the 2 to 3 year range, out at the latest 5 years, but most of the hyperscalers right now are looking as far as 10 years into the future of where they need to be and starting to make those plans today. And our counterparts, our friends at the utilities, are doing the same thing. They're looking at what the load requirements are up to 10 years into the future and trying to plan out what type of transmission upgrades are needed and grid upgrades to accommodate that continued demand. Thank you. Thanks, Matt. Thanks, Matthew. Appreciate you.
Thanks,
you.
team. Have a great day.
Take care, everyone. Bye.